Hi again, welcome back to Design 101. Today I'm going to be talking about the design process and its role in building a fully functional robot while also working hand in hand with the other sub-teams. Hope you enjoy! So what you see on the screen right now, hopefully it's right here, is the general guidelines that we strive to follow when we're going through the design process. If I'm being honest, it's generally not a linear process. We often zigzag back and forth between each step and turn around and go back and move forward a little bit, 2 steps forward, 1 step back, as they all say, as we trial and error different ideas. However, I'm going to go through each step with detail and let you know what we do in it and who it involves. So the first step, brainstorming and also the goal making, occurs in the first step of the entire design season at kickoff. So basically kickoff occurs at Western usually for our team, and that's when the gameplay and the rules are released at the university. There we are in a group and we brainstorm and come up with 2 or 3 functional ideals for the robot, and by the end of the day we try to have selected a design and some goals that are also attainable, while they also allow us to accomplish what we want to do in the game. Before starting any sort of aspect of design, the team needs to look at the competition in front of you and realize what you want to accomplish. More specifically, what are your goals in the time that you're given? This includes deciding your team's niche and its capabilities and what you feel that you can do well in this set amount of time that the build season prevails. It's also important to highlight what your team feels you want to accomplish, but what can be left until later in the prospect that you mess up on a prototype or anything that I'm going to be talking about in the future. It's also very important to determine what you want to do, because it's better to have a robot that can perform really well in 1 or 2 tasks than one that can just perform mediocrely in all the tasks that, even though every single team wants to be able to accomplish everything, it's really just not realistic. You got to make sure that you stay true to your team's capabilities, the time that you have, and the budget that you're setting for yourself. What we can achieve will give us points, carve a niche for our robot in competition, and allow us to be picked by an alliance. So the beginning of the design process is not focusing at all on finalizing ideas. It's more of to just begin the innovation and the train of thought that will work together to making those amazing ideas with contributions from everybody on the team. After kickoff and after the team decides on the best, usually 3 concept ideas, the design team, with the help of the other sub-teams, continues to grow on each subsystem idea while beginning to come up with specific details, materials, costs, time efficiency for each one to see which idea is attainable for the team. The team also has to consider how these ideas will work together and accomplish what you want your goal of your robot to be. It's also really important that you can take ideas from outside sources in the world or previous designs on your team. Don't be afraid to base things off of which are already proven to work. One thing that I think is really important to mention is that when you're designing your robot, you don't lose touch from the final constraints that will be put upon your robot, such as size and weight by the competition, or what allows for all the room for the different subsystems that you're going to be making. There's nothing worse than coming up with an incredible design that everybody in your team is happy with and then realizing that you can't do it because of different constraints. Plan out what your robot will look like from all angles early. It's also really important to keep the other aspects of your robot and design in mind while designing. It's not all about the individual subsystems. There must be room for electrical, batteries, bumpers, all of that as well. Just make sure you're planning ahead. So after all the main ideas and thoughts about the different subsystems or even the whole robot have been discussed in kickoff, the design team will then try to take these ideas and solidify them. This can consist of a CAD rendition, which stands for Computer Automated Design, such as AutoCAD or SolidWorks, which can show various parts of the subsystem, how they fit in the robot, and even adds the perk of being a 3D aspect, or paper drawings, which do not incorporate the 3D aspect, but they have the added bonus of being able to make quick adjustments and also be annotated really easily, so you can add points about your thoughts, about other people's thoughts, and just how they would all work together. When design and paper or CAD are a great idea to envision the separate ideas and how they come together, it's important to remember that design on the fly, even if it is just a drawing, is completely risky. You need to make sure that you're creating a drawing point for your robot will only be the starting point of your entire team for you to build on. Make sure that you're not set out to draw only your final designs. You need to be able to draw the improvements and create the improvements. So up here I'm going to put some examples of previous robotic designs in different CADs and even some subsystems that I've sketched out. When your team has a bunch of main ideas and individual concepts of subsystems are finally able to be conceptualized, the next step is prototyping. Prototyping is a very important step, as I discussed in our first video, as it is how you can tell if your theoretical designs will be able to work on a larger scale. It is really important to make prototypes functional but not necessarily perfect, as you want to spend most of your time perfecting the conceptualization of these ideas rather than making your prototype amazing or work perfectly. You also want to focus on your chosen design rather than to perfect a theoretical version that you may not even use in the long run. When prototyping, it's important to use cheap building materials. We often use like wood and screws rather than the metal that you would usually use when building a robot, allowing the team to gain a general idea on the function of the prototype without wasting valuable materials, which cost a lot of money. And we also don't want to spend any time being too finicky as it can be with the final materials that we usually use in the robot. It's also really important to prototype as it helps you seek and fix out possible errors in your design rather than as you're building the robot later on. As a build and design team, you must look at these different subsystems and how they work together and make sure that the designs allow for the complete flow of the complete function of the robot, and they need to work together theoretically and physically. I'm going to attach some examples of prototypes that my team has made in the past 4 years that I've been here, and I'll discuss on top of them whether or not they worked, whether or not we ended up using them, that sort of thing. So this first image here just shows the guys from a team building a prototype. Of course you can't tell what this prototype is. I just wanted to add it in to accentuate the fact that in this prototype they are using wood, they're using cheap building materials, nothing that we would make the final product out of. A prototype is just that, it's using cheap building materials, stuff that you can just find anywhere to kind of replicate what the final product would look like and give people a real tangible idea of how it might work and just allow them to see what's happening in the prototype. This second picture here actually shows a prototype from our 2019 first competition, Deep Space. Part of the competition was that we had to manipulate these large orange rubber balls, and so we wanted to create a sort of intake for that. Our idea was that we, as you can see here, we had some sort of claw and we would be able to move that up and down and shoot it out using motors. So for the prototype, we built it out of wood. We had really simple joints on the ends of it, and we had really basic motors on the end, which we would then connect to wheels. We didn't know if we were going to go with this final design, so this creation out of wood was just that. It was just a basic idea of how it would work, how it would open and close, and allow the team to see what the idea is. In this photo here, you can actually see that we did end up going with that design, and this is the final product. It's built out of metal with proper wheels, proper intake, and it was able to move up and down. It's actually pretty successful in the competition. This third photo here, I just added it to touch on two things. The first, you can see what the man is holding on the right part of the screen. That's actually a 3D printed kind of some sort of intake that we also had for the 2019 first competition, in which we had to manipulate those plastic discs that you see on like the right bottom corner of the screen. I just wanted to add this in because that intake part, it was actually 3D printed, and 3D printing is a great way to make prototypes. We didn't really have access to it in our early years as the team, but now we have a lot more access to it, and it's a great way to create different designs. For this one, we had different sizes of the clasp, we had different ridges on it, and it was just a really good idea to get different designs and see which one was the best at working. Another thing I want to add is that you can see the belly pan in the middle of the screen there, middle of the picture. That while this is not a conventional prototype, one way that we do prototyping is making the belly pan out of wood until we're sure of our final dimensions. It may not seem like a big thing, but if you make the belly pan where all the electrical is going to go onto out of metal in the first part of your robot, and then you change the dimensions of it, you're wasting that valuable material. So making it out of wood is also a great way to not conventionally prototype, but it still saves you time and is like a regular prototype as well. Okay, everybody, after you have designed and prototyped endlessly, not really, I'm joking, it's time to start the final build of the robot. I'm not going to elaborate too much on this as that is Clara's job. Hi, Clara. But I will leave you with some tokens of advice. As much as the whole design process works together in an effort to avoid making further mistakes, to avoid having to cut back on the work they've already done, and that's why prototyping design, you get the idea, hopefully by now. It's bound to happen that when you're building your robot, you are going to encounter some things that go wrong. The best advice I can say for that matter is that when you're prototyping, when you're designing, allow yourself adequate time at the end in order to fix those mistakes, things that you didn't foresee, because that will always happen. In fact, I've actually called on Gwen to tell us a little bit of a horror story from what happened when we were designing a prototype one time and when we left something to the last minute in the robot that we didn't need to. So I'll cut to her.
So there have been many times when we haven't created prototypes and it has backfired tremendously. And one of those times that I remember so clearly was the time that we decided to make a ramp for Power Up. And this game, Power Up, we needed to take one box and basically find a way to push it up and put it into a bin, kind of like basketball, I guess. And our team decided to make a ramp, and this ramp was comprised of a bunch of PVC pipes with dowels glued into them so that they could turn and push a belt, and therefore we wanted it to push the block all the way up and over the belt. We covered it with a bunch of this sticky mat stuff, and we thought this is for sure gonna work. We'll put some double-sided tape on it, it'll stick fine. Well, it didn't. We had to recreate these PVC pipes at least 3 times because the glue wouldn't work. We had to change the way it fit. We had to shorten them, lengthen them. There were so many issues with it. The cube actually never stuck. And we ended up having to scrap the idea completely. After scrapping this idea, we quickly realized that if we had made a prototype originally for this idea, we would have been able to avoid this entire issue and we wouldn't have wasted weeks and weeks and weeks of time. So basically, make a prototype because it becomes super important later on. Even if it seems like a pain in the beginning, it's a lot less of a pain to make a prototype originally than to spend 4 weeks of your time on one single subsystem just for it to fail.
So, I hope from this video you were able to see the importance of the design process and how it basically determines the success of the robot. In my opinion, of course, because I'm the design captain. Again, if anything I talked about today here interests you, such as the role of the design team in competition and kickoff, CAD, designing, brainstorming, prototyping, anything like that interests you, you should really consider joining the design team. Until next time.